The structure for the final model appears relatively simple, and indeed it is, consisting of 4 sturdy column towers incorporating Warren truss systems. Here, the Warren truss system is used to create rigid columns for the purpose of the intended experiments, where the roof is to be the focus. Each truss is arranged to create triangular prism columns because earlier experiments demonstrated that the triangular prism shape of the column offers several benefits in terms of aesthetics and structural stability. Further, Ching et al. Explained that equidistant or close placement of structural columns allows for the opportunity to use shorter spans between the columns to manage loads. Hence, this model places the 4 columns in a tight rectangle. The basic roof structure consists of 2 layers of joists, an upper layer and a lower layer. The roof has deliberately not been reinforced or braced, as it is expected to be able to swiftly demonstrate the impact of internal forces in the experiment to be conducted. The first experiment involves putting force between the 2 layers of roof joists. The roof frame contracts as the joists are forced apart vertically as the members are placed in tension when the balloon is inserted and slightly inflated. The most obvious deflection occurs on the longer sides of the roof frame, pulling the columns inwards to compensate for the tension stress experienced by the joists and roof frame. 2 of the joists on one end snap, coinciding with the location of the greatest amount of balloon inflation. Lateral bracing between the roof sides or directly from column to column would obviate the columns pulling inwards. Similarly, tension wires or diagonal cross bracing could be added between the columns to place them in compression and create an opposite pulling effect against the tension stress occurring to the roof joists when the balloon is inflated. The columns are then braced with wire acting as tensile members, fixed to the bench to prevent the columns from deflecting when the experiment is repeated. When one side of the structure is pushed towards the other side, the tension wires on that side are pulled taut, while the tension wires on the side to which the structure is being pushed experience slack, assisting the structure in reducing lateral deflection as lateral force is applied and load is transferred across the roof structure and between the columns. Simple weight experiments are carried out to demonstrate that the tensile members now reduce deflection in the columns, which are under compression, while the roof structure deflects significantly and is contemporaneously placed in tension. The final experiment relies upon the expectation that the 4 columns, now secured with the tensile members to the bench, will remain static while the roof structure will absorb the full impact of the inflating balloon. As the balloon inflates, the upper joists experience material failure as the tension stress exceeds the limits of the spaghetti, snapping dramatically. The bulk of the lower joists remain intact. If the goal was to reduce the propensity for material failure in the joists, various techniques might be employed, such as adding triangular truss support in the roof structure to carry the load to the sides, then to ground via the columns, or reinforcing the material.